Hi, thank you and welcome to Autodesk Eagle webinar. Today we're going to be talking about the Autorouter. The Autorouter is quite dependent on multiple areas of the environment within Autodesk Eagle. Primarily is going to be in regards of your design rule checks, as well as going to be fully tied to whatever net class settings that you have defined, whether either on the schematic or actually directly on the board. Jorge is going to be going live with Eagle today and giving us some demonstrations about ideas and tricks that you could do to optimize your use of the outer router. So Jorge Garcia is our primary expert here in the Autodesk Eco environment. So Jorge, can you take over?
Yep, so guys, just want to confirm that you can see my screen. My name is Jorge Garcia. I am Autodesk Eagle Support Specialist. And in this webinar, the goal is to help you become aware of how the Autorouter works, be able to predict its behavior, and then leverage that for your own designs. As the title says, to join the auto routing flock. So what we're going to do is we're going to start with the single-sided board. Okay, this is one of the example boards that comes with Eagle. Under Projects, Examples, you'll find this board there. And as you can see, it's a very straightforward board. Now, the way I'm showing it right now is not in its default state. And there's a reason for that. So what I want to make you aware of to start is what are the things that could affect the Autorouter's performance. Okay? So one thing we want to do is, before you ever run the Autorouter, go ahead and run the DRC. Just do a check. And this will give you an idea of the errors that could affect the Autorouter. So if you notice, we have a lot of restrict errors. Okay, practically every pad in this board has a restrict error. And what this represents is that if the restrict layers control the Autorouter's behavior. So if we have, for example, a top restrict, the Autorouter will completely avoid it. So in this case, it's not visible. I have that layer turned off, but it's always in play, as you can see by the DRC. So if ever you're running the Autorouter and you're noticing that things don't seem to be working the way you expect them to, this could very well be the cause. Okay, you may have a restrict error going on, maybe a clearance where the Autorouter can't get in between pads to route. So as a rule, the Autorouter will not route something if doing so will generate an error. So if you're on the Autorouter and you see there's a certain area of your board that never gets traces, or that doesn't seem to be touched much by the Autorouter, it's a good idea to run the DRC and make sure that there aren't any violations there, because if there are, the Autorouter won't be touching them. So of special interest are overlap, clearance, and restrict errors like we're seeing here. So let me go ahead and turn on the T-restrict layer. T-restrict, here we are. You'll notice that in Eagle we have 3 different restrict layers: T for top, B for bottom, and V for via. Okay, these are the 3 layers used to kind of control the location or the areas that the Autorouter can work in. So go ahead and say OK, and now you can see that all of this is covered in T-restrict. Now, why is that the case in this board? Okay, if you notice, the name of the board is single-sided, so the idea is that all the routing would happen on one side, the bottom side. Hence, by placing restrict on the top layer, the Autorouter has no option but to route on the bottom. So this is one mechanism you can use to kind of control the Autorouter in a very general way, but it is a way you can use to guide the Autorouter. So let's go ahead and click on the Autorouter icon. And let's go ahead and make sure that we have the settings the way we want. As you notice, the top layer is not available, so this is another way to control the Autorouter. If you set it to NA, the layer cannot be used. These other settings are preferred directions. So the first one is left to right, up and down, 45-degree angles going from bottom left to top right, 45-degree angles going from top left to bottom right. And these are preferred directions. In other words, Eagle will try to route along these directions whenever possible. However, if it can't, then it will do whatever it has to do to finish the trace. This last option, auto, requires some explanation. Basically, if you set the preferred direction to auto, you're allowing Eagle a variable to adjust when it makes routing variants, which we'll discuss in a moment. But basically, setting it to auto allows Eagle to alter this parameter from whatever you set it. The asterisk here, which I didn't mention, implies no preferred direction, an arbitrary direction. There's no preference. Okay? So let's check out some of the other settings. Here we have effort. You notice it goes low, medium, and high. What this does is determine how many variants are going to be created. So low will produce fewer variants than a setting of high or medium. Auto grid selection again gives Eagle a variable to tweak, allows Eagle to try different routing grids. That way you can increase the search space for a routing solution. Or if you have a specific grid you want all the routes to stick to, then you can go ahead and specify it here. The variant with top router, this is going to produce a variant that uses an auxiliary routing algorithm that's topological in nature. In other words, it's not grid-based, but rather shape-based. In general, these types of routers tend to produce results with fewer vias and that look a little bit more natural. Again, it's very subjective, the look parameter, the look benefit. However, the number of vias does generally tend to be lower when using the top router. The flip side of that is that it's mathematically more intensive, so it does take considerably longer to run versus the old kind of brute force rip up and retry routing algorithm. So you can choose, depending on the circumstance, whether you want to have a top router variant or not. And finally, you have maximum number of running threads. So per core, the Autorouter can run 2 threads. So if you have a quad core machine, as is my case here, you can have 8 variants running simultaneously. Now, up to this point, we've spoken a lot about variants. Now let's go ahead and define what they are. So if we notice, because I had the effort set to low, Eagle has produced 5 variants. Now, each of these variants is basically a separate run of the Autorouter, each of them tweaked to be different. That way we get 5 different results, and we can pick what's the best one for our application. So we can confirm what those settings are by just clicking the 2 greater than signs, and we can see the differences here. So if we notice, because bottom had been set to auto, each of these variants has a different preferred direction or a different grid, because also we had set the auto grid selection. So the first 2 variants have 25 mil routing grids. One of them is up and down, the other has left right for its preferred direction, and these other 2 variants have 12.5, but the difference between them is the preferred direction. So because these 5 are all different, we're going to get different results in our routing. And again, all of these parameters can be adjusted. Chapter 7 of the Eagle manual covers how these parameters interact and how you can kind of guide the Autorouter to route in a way that you prefer. Again, nothing can be explicitly guaranteed when it comes to the Eagle's current Autorouter. However, you can kind of guide it. You can kind of enforce certain preferences. So what we'll do is we'll go ahead and now hit start, and we're going to see that the variants 2 through 5 routed relatively quickly, whereas the first routing variant took a little bit longer. If you notice, all of them were able to route 100%. They all routed on the bottom layer because of the lack of ability to route on the top. And we can notice that they're all slightly different. So we have this one, this one, this one, this one. And at this point, it's really just a matter of which one you like best. Personally, I probably like either number 1 or number 4. Okay, at this point, let's say we had a much larger board and we were zoomed in, we couldn't see the entirety of the board. What you could do is you can click on Evaluate. You can go ahead and check out the route, explore the whole board, make sure you're happy with the end result. Now, one thing that's very, very, very important to keep in mind here is that you did not end the job. In other words, you have Eagle kind of in an intermediate floating state because there's still other routing variants that are in play and that are active. So in order for you to finish the Autorouter, you have to at some point hit end job. If you start tweaking things and trying to save your design and doing things, you're going to put Eagle into kind of an indeterminate state, and it could crash. You could have little issues with the routing results. So it's always important when using the Autorouter to end job at some point. Okay? So how do we do that? Well, now I've explored this one. Let's say I think I like the other one better. You'll notice that here on the far bottom right, you're going to have a little Autorouter job pending icon. Right click on it. You're going to get this warning. It says there is data available from the recent Autorouter job. If you want to continue to evaluate, changes to the current drawing will be lost. In other words, if I would have moved something around, made some adjustment, all of that would be gone because I'm going to evaluate other changes. If I want to keep this one, then I just hit end job. But let's say evaluate, and I want to pick this one. Now I know this is the one I want. I hit end job. Now the Autorouter has finished. Okay? So it's very important to always hit end job at some point. Now there's a couple of things here that I want to bring to your attention as far as Autorouter options. Like I mentioned, chapter 7 of the Eagle manual covers what all of the parameters represent. And there's a few sections of chapter 7 that are worth keeping an eye on. 7.6 is especially important. It's worth reading carefully. It explains each individual routing parameter, what sort of the typical values or usable values are for that parameter, and what each parameter does. This section is extremely valuable for understanding how the Autorouter works, how the old algorithm works, and how you can control it and guide it. Okay, in the case of that topological router algorithm that I mentioned previously, I mentioned that it's auxiliary. So what it does is it's not a complete replacement of the old algorithm. So this information is still valuable when talking about the top router. What the top router does is that it analyzes the board and produces kind of a rough sketch of best paths, and then gives it to our old algorithm to use as a guide when routing. And that's how we arrive at the final result. So some of these parameters are very adjustable, can do some very useful things. However, you have to be careful in modifying some others because you could end up creating a non-functional Autorouter. Now, to go into this deeper, let's talk about a use case, something that's actually useful other than just routing the whole board. Okay, in most cases, you're not going to want to use the Autorouter this way. The Autorouter, while it is obedient to the design rules, it is obedient to net classes, it isn't really thinking. It's just trying to connect points. Okay, so it doesn't have any concept of signal integrity built into it. It doesn't have any concept of what traces are low noise, which ones are critical in your design, none of that. Even if you set up net classes to a certain extent, that can help, but it doesn't replace the ability to know and be aware of how your design is supposed to work and what your critical traces are. So before leaving this example, I want to show just one more thing. So I'm going to go ahead and rip up everything. And one thing that's very important to know about the Autorouter is that it will respect anything that has already been laid out. Okay? So let's say we know that these two nets are critical. Then what we would do is that we manually route these beforehand. I'm going to make sure that I do this on the bottom. Okay, we route them manually. Okay, now keep a close eye on these two routes. Regardless of what the Autorouter does, these two routes will be completely left alone. So click on Autorouter. I say continue, and I'll just let it rip. Okay, and you'll see that it'll route, does everything. But notice that those are not moving. Doesn't matter what we do, those never move. Okay, so the Autorouter does respect any traces you place, and this hints at the proper way to leverage the Autorouter. Anything that is critical in your design, high speed, high power, low level signaling, anything of that nature, your RF section, those things you're going to want to route manually following your design criteria first, and then you can let the Autorouter go to town on whatever's left that is non-critical. Now, some designs are almost all critical nets. You know, if you're working in the gigahertz range, almost everything is critical. So you may not be able to leverage the Autorouter in that case. However, for most designs, or many designs, where the requirements are not as stringent, you can use the Autorouter to save yourself some time and some work. Okay, it looks like there may be a question. If a variant cannot route to 100%, how do you know when all variants have exhausted all options and are done? Very good question. The way that you know is if you see the word completed. Okay? When you see the word completed, that means that that variant can't get anything else done. Okay, it can't route any. As long as you're not seeing the word completed, the Autorouter is still running and you need to wait for it to finish. Okay? So, you know, just to reiterate, you always want to wait to see the word completed. For the runs that use the old algorithm, this tends to be pretty quick. This might be a few minutes tops, and even in a really complex design. The top router can take considerably longer. So sometimes you won't see the top router start routing. You may see it white for a little bit. Okay? If you are worried that Eagle has hung, go ahead and pick one of the other runs and you'll be able to see action and stuff moving around. Okay, so that's another tip. If ever it looks like maybe Eagle has hung and the Autorouter isn't running, just pick one of the other variants that's not the top router and you'll be able to see that it is. The top router does a lot of, like I mentioned, it's very computationally intensive, and before it does anything it goes through these calculations. So you'll see a white, you won't see any routes for a little while it's doing its calculation on more complex boards. Okay, so let's go ahead and let's move to a design that's a little bit more interesting, and that's going to allow us to show another useful case for the Autorouter. Control panel, let's go over here. This is one of my designs over here. This is Beaglebone Black Wi-Fi radio. Okay. So this is fully routed. I did this one manually. This one's totally by hand. Let me go ahead and rip it all up. I have to make sure not to save it. Okay, and we're going to look at a more useful case. So this board has three different ground planes. Has a digital ground, an analog ground, and just a plain ground. And this is because this chip that I'm using as an audio DAC requires three different power supplies in order to have clean operation. So if we go to the schematic, we'll see the three power supplies. Okay, and in this architecture they all come back to a single point. So what this allows us to do is try to keep circulating currents within the same signal. So currents that are noisy, for example a charge pump power supply, that tends to be a little bit noisier than what we want to have interfering with our signal chain. Hence that's its own polygon and only meets back to the power source here. Okay, so it's a technique that is often used to really guarantee some isolation. It can have some negative trade-offs, but in most cases this is usable and it works pretty well. So what we're going to do in this case is, let's say that I just want to do straight drops to the polygon. Okay, I want all of my ground signals to drop straight down to the polygon. So one way we could do this, obviously, would be to click on the route command. Say we start on top, we click over here, we can hit shift, and then to put the via, to go into via mode, left click, and then we drop off there, and we continue to do this for as many as we need. But that's going to take a while, and really it's a very repetitive process. So can we leverage the Autorouter to handle this for us? Let's go ahead and do it. So we're going to type auto, and we're going to, delineating by a space, type all the signals we want it to route. So in this case, I want all of my grounds to be routed. So I put DGND, AGND, and GND. I hit enter. Okay, and this pops up the Autorouter. You'll notice that those are the only signals that will be routed. So this is a technique you can use to make sure that you only get the signals you want routed to be routed. So if you notice, there's an option here for load and save as. I'm going to click load. Now previously I've set up configuration files for the Autorouter. Remember those cost factors I showed you earlier? Those can be saved as a configuration that you can reuse later on. You notice that I have two. I have via drop 2 and via drop 2 tighter. These are two that I will play with depending on the circumstances. So say we pick the tighter to keep them closer to the pad, and I say open. Now you'll notice that originally when I made that one, it was a 4-layer job, so I have to make sure to disable these. I hit NA, hit NA. For this one, I'm not going to use the top router because the rip-up retry algorithm is more than enough for this, and I don't want to spend the extra time calculating that variant. So now I click continue. You'll notice that I get 2 variants. Okay, and all I got to do is hit start. Okay, and in this one it failed. Why? Let's try that one more time. Nope. Okay, let me load the normal one. Set this to NA as well. Set this one to NA. Okay, continue. Okay, now it looks a little better. It looks like it hadn't. Oh, no, wait, no, because I didn't type in my signals. Auto, ground, EGND, AGND. Yep, that's true. I should have done that. Thanks, Ed. So yes, in the command line there's a trick where you can hit the up arrow and it'll pop up the last thing you typed in. So I'm going to load this one. Make sure inner layers are set to NA. Okay, bottom is available. Say continue. And start. Okay, good. So if we notice, we actually get the result we want. Looks like last time I missed a letter or something. But if we look here, if I say evaluate on this one, we'll notice that we get all the drops. Okay, now there could be the off chance that maybe it goes off and connects 2 pads together, but overall it's given us the result we want. Okay, which is straight drops to a ground plane. See, so here connected between the 2 of them, which is okay in this case. It's still a pretty short path to ground, but ideally you would want it to drop its own. But this is alright. Okay, here we see kind of a similar situation. Okay, but overall not a bad result. Very close to what we need, so we could always go and modify it. I'll right click here. Let's go back to evaluate. Let's check out this one. Say evaluate over here. You'll see this one also looks like it did pretty good. It's similar path, but as you can see, it is slightly different. It's not identical. But in this, I would be perfectly happy with this situation. So from here, I might route the rest manually. That way I make sure that I have my main signal path protected, but I've already taken care of all of my drops to ground. So this is a very useful way to run the Autorouter. Now, what's special about the file that I set up? Nothing much. If you go to the manual, and when you look at section 713, this is a very useful section of the manual. It shows you how certain configurations that we've already kind of worked through the support team and that we know works and can be usable in these situations. So the one you're going to be interested in to reproduce the result that I have is this one, SMD boards with supply layers. So what you do is you adjust these cost factors to match this. For me, I find that setting it to 2 or 3 works best. But as you can see, the recommendation is you can go between 2 and 8. So depending on your board, you can kind of adjust that maximum number of segments factor. That way you can make sure to get the results you want. Okay, so it's very handy, and I do encourage all of our users who want to use the Autorouter and really leverage it to the fullest to check out this section of the manual. So that's what we wanted to cover for today. Are there any questions? Okay, excellent. So what I'm going to do is I'm going to go ahead and kick it back to Ed for our webinar review.
Well, today, thanks, Jorge. That was good stuff, especially the one of yes, being able to route to a little bit off the pad to the polygon. That's always extremely useful. That comes up quite often, by which they want to use short traces to connect to a common polygon. Well, throughout this webinar, we kind of covered the different areas in regards of the Autorouter, how to launch it, how to get it to work with you, and the different parameters that actually exist that allow you to control it. The topological router is a great feature, but it does, you already mentioned, it always takes us a little bit longer compared to the other ones according to the different parameters. Also, having the capability of it automatically setting up different routing grids give it different possibilities to provide you different results that you could select from. Now, it's really, really, really important that you understand that you got to do the end job first before continuing doing any work. If you don't do the end job, it's a good chance that you're going to really lose anything that you've done from that point forward. Okay, because it's going to go ahead and load that board that was done when it finished and you did not end the job. So it's extremely important. Now, please remember, the outer router is following the rules from the DRC. So your DRC is imperative that you
Your volume's a little low.
it is imperative so match the parameters that you wish to use throughout the design. Okay. So if there's oh, okay. Sorry about that, Daniel. Is that any better? Okay, good. So it is imperative that you take a good look at your DRCs. Actually, it's always a common practice that you run into your DRCs actually before you start laying out the components on the board itself. Run your DRCs consistently. That way you know that your placement is correct. Then when you're going to start using the outer router, make sure that you do any manual routing that you want to do first, and then allow the outer router to take care of the rest. Now, remember, as I already stated earlier, that you could identify which signals you want the outer router to take care. The outer router will never touch anything that has been previously outer routed or previously manual routed. Okay. Hey, thanks a lot for joining us. That takes care of everything today. You could always contact us via email at any point in time if you have any questions. Okay. You could locate us at support.eagle at autodesk.com. That's support.eagle at autodesk.com. Okay, I'm Brandon. In fact, I just opened the man and started it. So, excellent. Well, Danny, you've selected the best program to start with. I'm pretty sure you're going to have a lot of fun. And we host usually 2 to 3 webinars every week. So I hope you join us for the future ones as we go along. Okay. Thanks for joining us, everybody. Have a great day.
Bye.